Hello everyone, my name is Guangyang Fang. I'm a research scientist at the University of Maryland. I'm the PI of this VR project. Today, we're going to show you how to use our latest version of the VR software.
Hi, my name is Ashmita Pine, and I'm a sophomore at the University of Maryland, College Park studying computer science. In this project, I've had the opportunity to learn Unity, as well as work on projects outside of just the classroom.
Hi, my name is DJ Figueroa, and I'm a sophomore computer science student here at the University of Maryland. I'm also one of the virtual reality developers working on building this weather visualization application.
Our project investigates the well-known El Niño and La Niña weather phenomena. These are climate patterns that periodically warm and cool the equatorial Pacific Ocean and affect global weather patterns. El Niño and La Niña make up phases of a cycle called the El Niño Southern Oscillation, or ENSO for short. These phases alternate every few years, where the El Niño phase has warmer than usual sea surface temperatures and the La Niña phase has cooler than usual temperatures. To help visualize El Niño and La Niña, we upgraded our previous virtual reality weather visualization application and redesigned its control panel to make it easier to use. We have implemented a series of long-term oceanic climate datasets from 1901 to the current day to demonstrate historical ENSO events over time. In our datasets, we include two types of sea surface temperature data, or SST data for short: optimum interpolation SST and extended range SST. The optimum interpolation data has a higher resolution of sea surface temperature data, whereas the extended range data has a greater time span of the data. We also visualize other data such as sea surface wind stress, thermocline, precipitation, and outgoing long-wave radiation, or OLR for short. These datasets and their anomalies are listed on the sidebar menu on the left. By clicking any of these datasets, an inspector panel will appear on the right, which shows the dataset's brief description, visualization controls, a legend for interpreting the data, and other metadata related to the dataset. In the middle panel, there is a map view that displays a 2D representation of all the visualizations. Beneath that, there is the timeline which controls the temporal playback of the data selected, and you can also display a precise date by clicking the Date Selector button. For example, December 1988 is the strongest La Niña event in history, and December 1997 is a very strong Eastern Pacific El Niño event. There are also a series of quick controls at the very bottom which help to manipulate the globe and its visualizations, such as the cut tool that we'll demonstrate later. We will also soon be restoring the pencil and measuring tool to allow for annotations on the globe like in our previous weather application. With virtual reality, we are also able to intuitively demonstrate the thermocline behavior of ENSO. Let's examine the El Niño thermocline by using the cut tool to take a cross-section of it across the equator. As we can see, there exists a transition layer between warmer mixed water at the ocean surface and cooler water down below. During this time, the Eastern Pacific warms up, the trade winds weaken, and the thermocline becomes abnormally deeper. This depresses the upwelling of the cold water from the deep ocean, which makes the region even warmer, and this is sometimes referred to as Bjerken's feedback. Now, let's introduce how we can use our virtual reality application wirelessly and remotely on our central computer within the Proving Ground lab here at CISSS. We believe that the ability to remotely stream this application will be highly beneficial for remote education and training in virtual reality. Let's look at a demo of how this would work. Suppose I am the student and I am learning from my mentor Dr. Fang and that we are at different locations. Dr. Fang begins by logging into the central PC with his Meta Quest via virtual desktop and interacts with our virtual reality application running on our lab computer. I am able to watch his perspective by using a screen sharing application like Zoom. In this demo, we use the virtual reality streaming software Virtual Desktop, which only allows one user at a time. Therefore, to try it out myself, Dr. Fang disconnects first so that I am able to log into the lab computer with my Meta Quest. In this way, users would be able to log into the server anywhere, as long as they have a stable internet connection. This makes our VR application more accessible to those who lack the powerful computer hardware currently needed to run our application. Currently, we are exploring more effective ways to offer remote virtual reality education, such as a custom virtual reality streaming client and a multiplayer standalone application for the Meta Quest that wouldn't require any external PC. Additionally, we are working on real-time processing of weather data, which could allow National Weather Service forecasters to improve their forecasting skills and better understand and analyze their weather events. Thank you for watching, and we hope you'll be able to try our application soon.